give me a moment. Look at Open Circuit Sim, and we've actually got a surprise mini project for you at the end. So she's going to take the first half, and I'm going to take the second half.
Okay, so just to let you guys know, as a reminder, basically what this project is where we want to simulate graphically logic circuits and analog circuits, and I'm working on the back end, and Matt is working on the graphical interface. So updates to the back end so far. We mostly worked on little parts because we're trying to figure out right now like how to do the graphics. So in the back end we just like focused on little parts. We improved some efficiency. We got it running faster and took out a lot of bugs. And one of the big things that I implemented a lot of the 7400 series, the integrated circuits chips. I just made a whole bunch of those, a library of those. So you know, like the quad 2-input NAND gates and things like that, and the multiplexers. I put in a bunch of those, so you can use those. And I put in flip-flops. We have D flip-flops and JK flip-flops right now. And I just made those, so I'm testing them out, and they're working pretty well. And of course, I had to implement clocks to do that. And as far as I can tell, those are working. I just did those. So that's what we have for the back end now. And just to give you a quick overview of how the back end works, it's pretty simple. Basically, like if I were making the circuit, how it would work right now is you make a structured circuit, and then you just basically call like I just want to make a NAND gate with like these inputs, and you can just make it and then you put it into the class, and the class takes care of all of the inputs and the outputs, and if you want to evaluate the outputs, it figures out how to do that. And if you call, like if you want to change this value from 0 to 1, it does it in a really efficient way. And that's basically how the back end works. Really explain it. So our goals right now, obviously, it's not up here, but we really, really need to work on the graphical interface, and we've been working on that. We've completely overhauled it because what we were doing was not working, and we need to integrate the graphical interface with the back end. That's obviously the most important part. But I want to complete like a library of like logic components, like obviously I made the 7400 series. The integrated circuits. I'm going to make some more things like that, you know, make some more flip-flops and latches. I want to implement something that can take the circuit, like an equation you've made, and show you like the K-map of it, and show you how the best way to represent that circuit is. And obviously analog circuits, that's what we really want to focus on, and that's what I'm going to be doing this summer. Mostly, is going from logic circuits to analog circuits. That's what we really, really want to do, and that's why we started this project. Okay, so if you remember our last presentation, we made a 2D renderer for the circuits for our graphical interface, and we started integrating that, and we were looking at the same time, we were looking at implementing the analog circuits, and we realized that with the analog circuits, we want to be able to do things that really require 3D display. So we scrapped the 2D renderer, and we made a new one based on Ogre 3D, just because we don't want to do all the 3D stuff ourselves. And that's currently in early stages, but it's working and it renders stuff, and we're integrating it with the back end. And on that note, ended up starting another open source project this semester just randomly. You'll notice that there's an extra name on there. That guy's an extra dev we have from Temple University, who's on the who's helping out with the project. So what is this mysterious project? So if you look here, this is a game from a software architecture standpoint. And what we're really focusing on is this part, which is what people traditionally consider to be the engine of the game. And notice we have, I mentioned a library earlier, Ogre 3D. It's just a rendering toolkit. And you see the things in green, they're handled by something like Ogre 3D. They do like scene management and animation and stuff for you. And then there's the components in yellow, which are really independent of any type of application you want to do. It's like, if you're making a 3D application, you want, collision in physics is
fairly independent of the game. Accepting input is fairly independent of the game or whatever. So then we have the red systems, which are things that are fairly dependent on the genre of the game that you want to make. And those things would be very different between, for example, an engine built for a first-person shooter or a strategy game, where the green and yellow systems would remain pretty static. So what this project aims to do is make a unified add-on to Ogre 3D that provides everything that isn't genre-specific for making your own engine. So the goals, we want physics, audio, interface, networking, and just a basic library of pre-baked shaders for things that you normally want to do. Obviously, you want to do something special, we wouldn't do that. But then we want to make it, there are some really nice actual engines that have set things up. Like Unity, you can just say, oh, I want to build this for check these platforms, and it'll build it. So we're setting up a unified build system so that you can start, we're starting out on Linux right now. We're making the unified build system so you can just cross-compile to Windows, Linux, Mac. This is our progress. It is cross-platform already. It is Windows, Linux, Mac, Android, iOS. The unified build system, it's getting there. It's kind of working. It's done a little bit shoddily right now. We actually maintain a slightly modified version of all of the dependent libraries right now because we had to modify their build systems to fit our multi-OS model. Actually, if anyone was on the RCOS IRC the other day, I was asking for places you can host multi-gigabyte repositories, and that's why. So we're looking to fix that. We have physics support. It doesn't have the kind of clean interface like code interface we want yet, but it's integrated, working on all platforms, and we have some subset of the shaders built in. So I'm just going to show you a quick demo of that. Running. Oh. Okay, this is just using some random art from a different project. You'll notice I'm just throwing ogre heads that come from the ogre project at this random sky, and they're colliding with the sky and with each other and doing general physics things.